Hey everyone, here's Simone from the studio. Welcome to this new video. This time, we will speak about attributes in Touch Designer. And as you can see, we have already some network build. So to do this lesson. This file will be shared on my Patreon. My Patreon is free for members. You are more than welcome to support my mission of teaching Touch Designer. Okay. If you navigate here, we have an example made on SOP. As you can see, they are also powerful since we're using the template attributes. Those template attributes are the array of data that the geometrical stream can interpret. You can access attribute in the subclass. Actually, we speak mostly about point attribute this time. You can access them with the point sub. As you can see, I'm using two of those, one to set the color of the sphere and one to sample a noise which is containing our display. Let's analyze a bit the point sub. Here we have some drop down, and if you go in particle, we have even more of those. And they are some pre-made attributes that the geometrical stream can read and do something. If we activate, as I did here, the scale attribute, we can then define a scale. If I move it, all are the same. The cool thing is that I can sample a value for each one of those attributes. We can see what we are creating by converting the sub to a dot and staying on the point level and analyze the newly created scale attribute. Okay. We can see that in the dot here, we have an index and we have a p-scale. A thing that cannot miss of a pointer is a dimension in space. So it's a point in space. And if it's part of a geometry, it has an index. The index is basically, if we actually see the index, is a ramp that is going from 0 to the number of the point we have. They break. Yeah. Let's go. Okay. As you can see, we find out that the index is around, which is going from 0 to the number of points contained in our grid. This is very important because I'm using it in this expression, so to sample the noise. If you're not very much familiar with Python, this means go to the operator called noise, get the first channel, which in this case is a multi-sample channel, so I can then refer to the sample index by using the actual index of the geometry stream. This is common usage of the point sub and the index. Okay. By creating this randomic value, we can then use it automatically inside of the copy sub, which is giving us this pattern of spheres. It is not the fastest in operation in the world, but it's okay for our purpose of showing the computational functionality in SOP. Very good. Let's make a tiny dive that's very small in Python. Okay. So Touch Designer is a Python environment, very open, where we can actually work with the text file and they can contain Python that can be interpreted. In this case, I am using vars and I am interpreting vars as a module. A module can be any dot nearby another dot, this example, which can contain some eligible Python, meaning the interpreter can understand what's inside here. In another text data, which is containing eligible Python, I can then run a script. Let's run this one. I just press Alt-T to open the text port, or you can go up here, somewhere, text port, yeah. And by selecting this one and doing Control R on your keyboard, you run the selected dot or right click and run. As you can see, I print 200.0 and a 0. Why? Because I am importing this guy, which is containing an attribute called myval. Okay. This is a variable inside of my script, which is becoming a module. So then this is becoming an attribute, okay, of this module. Well, you can read it. And very formally, you can get the attribute from a module with the expression is described here. So you need the module, the attribute name, and at default if nothing is found. In this case, I demonstrated by changing the default to null and I run it. Okay. The null is given because I am searching for val, which is not the name of our attribute. So to avoid errors, you can give a default value. Okay. As you can see, we are also evaluating what is written here, which is referring to this placeholder for a value. If I type 350 and I run the guy again, you have 350. Very nice. Okay. Faster run in job. In job, if we go in our tab menu, we go in job family, we can actually search for attributes, and we have this guy. If we read the description, that change if I select it, you can get a sentence which is telling you currently there is only one type, Aquaterion, so meaning you can only have one type of attribute, job, which is kind of hard to give you an example in this tutorial. So you know that we have an operator which can create attributes for defining quaternions. It's kind of complex. So I am showing you how to deal with custom attributes stored in a SOAP and that you can then use to create and interact with the render. As you can see here, I know when my mouse is above a certain geometry, and if I click it, I got interaction. The basic of a SOAP UI based, UI based in SOAP and attribute, we can say, okay? And the pipeline of this example is as follows. I have a point SOAP. This point SOAP is creating in the custom page a custom attribute called grid one. This attribute is just one. So for all the points that we have inside here, we have an attribute called grid one, which is one. Okay. I do a render. Okay. And the render is showing me this rectangle. Okay. I then need to set up a render peak as follow. You drop a render peak chopper that must be defined like this. So you need a top to read, and this top must be rendered. So a render or a render pass like this. Then you actually need a container, which is actually showing our top as a background, and it's the same size. Okay. You assign this container as the panel. This is the setup you need to do. So this goes here, and this goes here. You're done. The only things I change here is the strategy of the channel we want to have. I set it to always, meaning I can have the rollover and the cake is the trigger. So you see, as soon as I roll over the grid, I can get the attribute. Why? Because the last things you need to set up is to go in the option, and the render picture can read 4 custom attributes. So if you have more than 4, maybe you need more than 1 render pick. And for those, you can then get the value we're storing here. So let me demonstrate this. I go above here, I have 1. When I click, I have a trigger. If I put 10 inside of here, and I go inside, you see? Okay. Then to demonstrate that this is per point, we could actually brutally copy this expression, which is doing the point scale in this one, drop it here. Right. And if I'm not mistaken, then yeah, actually here you would, because you need to change it to float. Yeah, so now it should be pardon. If you set it up here as a float, you need also to set it up here as a float. So in the option page, you go to float, and then you're basically reading the value for the point where the mouse is above. Okay, the color is flickering because it's reacting to it. Okay, so you put back this to integer and you set this to 1. You're back in the situation where you can have a click. Basically, you have a volume value to work with. Okay. Attribute in top. Okay. Basically, here we are doing instancing. Nothing more than that. Okay. I do have a network which is moved by a noise, which is expanding forever. And I am limiting with a bounding box. This is giving the bounding behavior. It's not the best way to showcase a particle system, but it is very fast. Because this can go very fast. After that, I don't know, some hour. This noise is actually creating what? A texture containing our position, as always. Okay. And this position is then used as the attribute translate in our instances. Why we're using instances to showcase attribute in top. Then I am creating some color just to demonstrate that we can create more than one. Consider the attribute in top. I'm showcasing them as instances. So the result box here inside of a box. Very nice. Okay. And then maybe it's not very much correct in term of what is an attribute, but you can even send, let's say, a color, which in this case is like back 4, because it's a value containing four other values that are floats. Okay, so it's a back 4. You're representing a color. Right? Making the code as small as I could is this one. So we need to set up the vector here and set it as output. And so you declare that you want to use this vector, name must match. You need to tell the video card, send this to the frame buffer, and what you want to do with frame. Okay, meaning that yes, I am now rendering 1 pixel, but they can go in parallel any number of pixels of the same. Okay. Not pretty much an attribute, but yeah, makes sense to have it. Okay, finally, we arrive here to pop, which is why I'm doing this lesson. I drink a glass of water and I'll be back to you. Okay, I'm back. We were speaking about pop. I made this tiny network which is creating this animation. Okay, we have a grid with some torus copy on it. And as you can see, I am applying transformation to the point of the grid and to the torus, rotation and size, and color as well. I find out that an elegant way, let's say, to colorize your field. What are those fields and why we care about attributes? So the field pop, this tiny operator here, has inside some theoretical shapes that can be defined by math, basically. All of those. So the distance from a mathematical shape can be easily and very fast calculated. Okay, this is what is doing the field pop. If we input a grid, and I encourage you to work a bit bigger, so we make this like 10 by 10. Okay. Oops. I activate the viewer and I center it with the edge. I have now a very big grid. The field is already active by default when you connect it, and is writing its value in an attribute called weight. So now we are creating a sphere. I change it to torus. The torus have 2 radius, and I'm good with it for now. And it's in the middle of the axis. So we are expecting to see something here. Now I believe. Okay, after that, after those weight, I want to create another attribute. So we are creating this weight attribute, which is a float. We can have a confirmation by see in top, in top, why not? We have the weights. Let me see where this. Okay. So I do not expect it since I select torus, but by default is epsilon is our height, is our the height is epsilon. So if I rotate by 90, see if I drop a torus, the same position and create it inside of the field. As you can see here, we are scaling. We are defining with the torus some point on our grid. So this is the mask, basically. Okay. We do not want to use top to assign a color, even if we could. So we create an attribute, an empty one, which is already defined by the designer and is one of the template attributes. It is called color. A 3D object basically have like position, which you cannot miss. Well, you cannot create it, must be in the pipe. You can have normals, color, texture, and some stuff, for instance, in like point scale and with the same as shop context. Very nice. And here everything is black, I make everything white. Okay. So if we can then explore here with this, we want to see what color do we have here. We can see it from here, but if we want to also see it in top, we can ask for the color. But well, everything is white. Very nice. I would like to combine these two things. Okay, usually in top you do multiply and you apply a mask over something. Okay. You can do the same things in attribute. Okay. With I don't know, mat mix or mat combine, doesn't really matter. It's a simple operation. So I am using a mat mix. Okay. And we do A times B as easy as it is. And A times B will actually give us a the result we want. So I can take the color and we can multiply the color for the weight. And we're actually seeing where is our field. Okay, to demonstrate that the field is there, beside coloring, you can take a transform, pop, and say that you want to use the weight attribute. We create, you want to use it. We have a drop down for it. And this is working on points. And we want to move something in the epsilon plus direction. So we have one with the axis. And as you can see, I am moving only those points a certain amount on the direction. We will sort of take them. Okay. This is what is done here, basically. Another trick that can be really handy is to use noise so to create randomic values, because you should drop the random by default. If you set something can only be a float, so you can't have randomize more than one, and they find out also that the control is very handy. Do it like this, so to have a random value from an empty attribute is very handy. Now I show you how I'm doing this. So again, we continue this example. No, okay, that's the other one. We take a grid. Okay, so here this is our amount of point. Okay, and I want to create something, an attribute, exactly, an empty one, and I can do this with an attribute pop. You already know, for this example, I want to show you this with a color. So I noise the color, so I have only alpha for now. This is not transparent. This is with alpha. And we actually create a color. So down here, you see, if an attribute is updated or created, we will list it here. So you can see where the operations are happening, in which attribute and which operator is affecting what attribute. We can then use a noise. Okay. And you see the noise lookup attribute. This can either stay P or maybe, let's say, text. So we know we want to apply it on the grid. Maybe text is better to noise a color to make more sense. So set it up as text. And now you want to go in output. This is way more complex of the noise stop. And the cool thing is that you can use this drop down to generate or noise existing attributes. So, for example, now I am, of course, modifying P because it's here, but if I say it's doing nothing, okay. And also I am exporting the noise as an attribute in case I need it. I don't want this. You see now only the P remain. And but I want to noise the color. So I can say you are generating a noise. Please add it to the color. And on the other, we are creating a noise texture, which can then use. Okay. Use a very handy way how to generate an attribute and then a randomic version of it. I'm doing the same things on the point scale. For the point scale animation, I made a tiny trick, which is kind of complex. Okay. So look what happens if I bypass these normals. There's not anymore protecting. Okay. This is because you can set up the noise in a weird way, which is we actually want to use the normal as lookup attribute. So we know that they go from 0 to 1. So we good as the sampler. I want also to output the noise and affecting what the point scale. So I'm also scaling them while they're moving, and the normal are being updated in real time while the geometry is animated here. This not form. Okay. So now here I am containing a lot of values that I like, and I can copy. Here's the copy pop. I can copy this torus, and I can then refer to the point scale, the normal, which I am recalculating to rotate the torus accordingly, like this. And I can then pass from the template, use bitten template to the copy, some attribute that you can define here. If you turn on off this one, you are only affecting the point position of the template, so to move the torus. And here we are passing other two things, which are the template attribute that you can select from this dropdown. The template attribute here is a bit misunderstanding because you do have template attributes in SOP which are predefined attributes. Here the template are named template because of this input. Be aware of that. Okay, first animation done. It's becoming kind of long. I hope you're still with me. Okay, then let's create this. You like it? I do. So this animation is done by a clever use of the extrude pop. Okay. The extrude pop works on primitives. So here we are just working with points. We want to work with primitives. Primitives are actually a derivation that you can have from a point pool. By connecting them with vertices, you can then smash a face there and call it primitive. Okay. In this example, I want to showcase also that I am not passing the normal because it's a waste of computation. So things we should always keep in mind working with pop. The normal are creating at the end. So maybe you can see this white thing here as nothing, and then passing to the normal and I'm getting the light capability, so it can have a material on it and light reaction because they're normals. And so until here I didn't pass it through to avoid something I don't need. How to do this? You basically say that starting from a sphere, if you say no, if you set normal to point, you can have it until here, but then here they breaks. So I prefer not to. Yeah. Okay. Little explanation why we're seeing a white shape. Okay. Okay. Network. We have a sphere. The sphere, I am noising the point of this sphere. Very nice. This attribute combine is doing a trick. It's doing a copy of P. What are P? P are the points composing this object. Okay. I am doing a copy because you should not. Maybe you can, but it's not graphical because you then lose the viewer. You should always have P, which makes sense. It a 3D object must have position. Okay. So I am passing to the next stage P and N as they are, but I am doing a copy of P and call it P prime. Why? Because then here I am converting this attribute, which is in point level, to primitive. If you convert the point position from point to primitive, you basically have the center of the primitive of each one. Okay. All this trick is to use this field here. Okay, because this field here must the field must align a set of points, because you need distance here, so you need to run on a set of points. Okay, this set of points, in my case, since I want to use the extrude, must be in primitive level. Okay, so let's see, and I show you the difference between what is P and P prime basically. Here I am getting E, which is a vector, and we have the alpha that is needed to showcase the image. So this, see the point that I'm noising. Okay, then I want the center of each primitive. Center of each primitive is not actually changing even if the primitive moves. So I am expecting something that is not moving. I can then change my height to primitive and select P prime. Not moving at all. Okay. So as you can see, the difference. The difference is also in point 20 times 20. This should be 20 times 20. So 20 primitive. Apparently, yes. Okay. So this is the translation. Okay. What I'm doing here, I am assigning the weights. Okay. Why are those weights very important? Because they come from a field, and the field is a position in space, which I can change and have this kind of, I don't know, I can see for this kind of MoGraph behavior when you pass an vector and you're doing come on, doing this. Okay, very nice. Okay, as you can see, if I move my field in space, I can affect different parts of the geometry. If I now put it up, the down part is not anymore affected from the extrusion. Okay, same things, I guess. Let's do a bit of freestyle at the end. I guess you can even colorize this guy. Let's see. So I can convert back to freestyle pop. I can convert, let's see. No connectivity, I need to convert. I can convert from primitive. I need to convert an attribute. Yeah. Attribute convert. I can define the I want to go from primitive to point, and I want to change the weight. Okay. I can then actually do the same trick I learned from here to put the color on a value, basically. So I can then take a matte mix or matte combine after simple operation, and I can do 8 times B. So I'm going to first create a color. Exactly. And then I want to matte combine 8 times B, and I want to multiply the color for the weights. You want to open the color. Yes, I'm correct. I need a color to be multiplied. Exactly. So as you can see now, the extruded part are becoming more red and mirable. So it's kind of animation. It's very cool. They said this like 0.1.1. So we have an overall reddish color also here. Okay. So I hope you like this very long trip in with attributes in Touch Designer and understand how powerful they are for geometry manipulation with pop. Thank you for your time, and if you want to support my work, you find this in my Patreon page. Ciao, ciao.